Today we are going to discuss the topic frequency response of LTI system. A general linear constant coefficient difference equation for a LTI system with input x of n and output y of n is of the form summation k is equal to 0 to n ak into y of n minus k is equal to summation k is equal to 0 to n bk into x of n minus k. Call it as equation number 1. It is advantages of several properties of DTFT to determine the frequency response h of e power jo for a LTI system is described by such an equation. Let x of e power jo, y of e power jo and h of e power jo denote the Fourier transforms of the input x of n, output y of n and impulse response h of n respectively. That is, in the block diagram representation it is given x of n is the output and y of n is the x of n is the input and y of n is the output, where y of n is equal to h of n star x of n. The convolution property of DTFT implies that y of e power jo is equal to h of e power jo into x of e power jo, or h of e power jo is equal to y of e power jo divided by x of e power jo. Applying the Fourier transform to both sides of equation number 1 and using the linearity and time shifting properties, we get summation k is equal to 0 to n ak into e power minus j ko into y of e power jo is equal to summation k is equal to 0 to m bk into e power minus j ko into x of e power jo, or h of e power jo is equal to y of e power jo divided by x of e power jo is equal to summation k is equal to 0 to m bk into e power minus j ko divided by summation k is equal to 0 to n ak into e power minus j k into o. For example, consider a discrete time LTI system described by the equation y of n minus half into y of n minus 1 is equal to x of n plus half into x of n minus 1. Determine the frequency response h of o of the system and find the impulse response h of n of the system and determine its response y of n to the input x of n is equal to u of n. Consider the given equation y of n minus half into y of n minus 1 is equal to x of n plus half into x of n minus 1. Then, taking Fourier transform on both sides of the given equation, we get y of e power jo minus half into e power minus jo into y of e power jo is equal to x of e power jo plus half into e power minus jo into x of e power jo. Taking y of e power j ohm common, we get y of e power j ohm into 1 minus e power minus j ohm divided by 2 is equal to x of e power j ohm into 1 plus e power minus j ohm divided by 2. Then h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm, which is equal to 1 plus e power minus j ohm divided by 2 divided 1 minus e power minus j ohm divided by 2. Consider h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm is equal to 1 plus e power minus j ohm by 2 divided by 1 minus e power minus j ohm divided by 2, which is equal to 1 divided by 1 minus e power minus j ohm by 2 plus half into e power minus j ohm divided by 1 minus e power minus j ohm by 2. Taking inverse Fourier transform of the above equation, we get h of n is equal to half to the power n into u of n plus half into half to the power n minus 1 into u of n minus 1, which is equal to half to the power n into u of n plus u of n minus 1. Next, consider h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm, which is equal to 1 plus e power minus j ohm by 2 divided by 1 minus e power minus j ohm by 2. And it is given x of n is equal to u of n, then x of e power j ohm is equal to 1 divided by 1 minus e power minus j ohm, and y of e power j ohm is equal to 1 plus e power minus j ohm divided by 2 divided by 1 minus e power minus j ohm by 2 into x of e power j ohm. Now, substituting x of e power j ohm is equal to 1 divided by 1 minus e power minus j ohm. We will get y of e power j ohm is equal to 1 plus e power minus j ohm divided by 2 divided by 1 minus e power minus j ohm divided by 2 into 1 divided by 1 minus e power minus j ohm. Then, using partial fraction expansion, y of e power j ohm is equal to a divided by 1 minus e power minus j ohm by 2 plus b divided by 1 minus e power minus j ohm, which is equal to a divided by 1 minus s by 2 plus b divided by 1 minus s. Then y of e power j ohm is equal to minus 2 divided by 1 minus e power minus j ohm by 2 plus 3 divided by 1 minus e power minus j ohm. Taking inverse transform, Fourier transform of the above equation, we get y of n is equal to minus 2 into half to the power n into u of n plus 3 into u of n, which is equal to 3 minus 2 into half to the power n into u of n.